Today, we're diving into a fascinating paper called IoT-Based Indoor Air Quality Management System for Intelligent Education Environments. It's all about how the air we breathe in our schools and universities impacts us, and more importantly, what we can do about it with some seriously smart tech. This fantastic work comes to us from researchers Jesus Rosa Bilbao, Fatima Sajid Butt, David Merkel, and their colleagues, and it was published in the IEEE Internet of Things journal. So to really get why this research is so important, we have to start with a couple of pretty shocking numbers. All right, get ready for this. Most of us spend up to 90% of our time indoors. I mean, just think about your day. You go from home to your car, to your office or classroom, and back home again. We are, for sure, an indoor species. Now, here's why that 90% matters so much. The World Health Organization estimates that indoor air pollution contributes to about 3.8 million premature deaths every single year. It's a huge, often invisible health crisis. And that brings us right to the heart of this paper, the classroom. I mean, these are places where we expect our kids and young adults to be focused and learning, but what if the very air they're breathing is getting in the way? So here's the deal. Poor indoor air quality, or IAQ, isn't just a minor annoyance. It can lead to headaches, fatigue, and dizziness. And in a school, that's a recipe for disaster. We're talking about pollutants like tiny PM2.5 particles and high CO2 levels that can actually hurt test scores, make students miss more school, and just tank their ability to learn. Okay, so you've got this invisible threat. How do you fight it? Well, the researchers' idea was brilliant. They decided not just to measure the problem, but to build a system that could actually get ahead of it. And this is their blueprint. It's a 3-layer system. Down at the bottom, you have the data acquisition layer. This is where a bunch of custom-built sensors are grabbing raw data from the classrooms. That info flows up to the middle layer, data processing and analysis. That's the brains of the whole operation. And at the very top, the data consumption layer takes all that analysis and does something really important with it. It creates a secure and transparent record of any critical alerts. So, what's the secret sauce that makes this whole thing tick? It's not just one thing. It's a powerful combination of 4 cutting-edge technologies working together. Let's break them down real quick. First, you've got the Internet of Things, or IoT. You can think of this as the system's eyes and ears. These are low-cost sensors that the researchers built themselves, constantly sniffing the air for things like CO2, dust particles, temperature, you name it, all in real time. Next up is Complex Event Processing, or CEP. This is like the system's central nervous system, its reflexes. It's constantly watching the flood of data coming from the sensors, and the second it spots a pattern, like a sensor going haywire or a sudden spike in pollution, bam, it knows. Then, of course, there's the AI. This is the system's predictive brain. The team used a specific kind of AI called LSTM to actually forecast what the air quality would be like 10 minutes into the future. And they used another model, a decision tree, to find hidden connections in the data that a human might never spot. And finally, we have blockchain. Think of this as the system's unbreakable diary. Whenever the system flags a really serious event, like dangerously poor air quality, that alert gets logged on a blockchain. That means it's secure, transparent, and nobody can ever go back and change the record. It's a permanent proof. Now, this all sounds amazing on paper, right? But the big question is, does it actually work in a real building? Well, that's exactly what the researchers set out to prove, setting up their system in lecture halls at the Frankfurt University of Applied Sciences. And one of the most incredible parts of this project is the cost. Just look at this table. Off-the-shelf commercial sensors can be super expensive, and you can't really tweak them. The researchers' custom-built station, it cost only about 210 euros. That makes it a real-world, scalable solution for schools that are often on a tight budget. And here's the little guy himself. On the left, you see the case, designed to let air flow right through it, and on the right, you get a peek inside at all the components, the microcontroller, and all those different sensors packed in together. Pretty cool to see the hardware that's making all this happen. Okay, so the sensors worked, they gathered the data, but the real magic is what the AI did with it. Just how good was it at predicting the future? Let's start with PM2.5, those really nasty little particles. The blue line is what was actually in the air. The orange line is what the AI thought was going to be in the air. I mean, look at how closely they track. The AI's forecast was unbelievably accurate. And for CO2, it's the exact same story.
That orange prediction line is practically hugging the blue line of real data. You can even see those big spikes, which probably happened when a lecture hall filled up with students. The AI saw it coming every time.
But here's where it gets even cooler. The AI didn't just guess numbers, it actually learned rules. This decision tree shows us what it figured out. It discovered a super important connection. When CO2 levels go up, PM 2.5 levels are very likely to go up too. That's a huge insight for managing ventilation.
So, when you put all this together, what does it really mean for the future of our buildings? What are the big takeaways?
Well, it really boils down to this. This research gives us a blueprint for a system that's affordable, that's smart enough to predict problems before they happen, and that's secure enough to create a trustworthy record of our environment. It doesn't just react to bad air, it outsmarts it.
And that just leaves us with this incredible thought, right? What if our schools, our offices, our homes, what if they could think and breathe for us, proactively making sure we're healthy, comfortable, and at our best? This research shows that future might be closer than we think.
And that's a wrap on our breakdown of the paper, IoT-Based Indoor Air Quality Management System for Intelligent Education Environments by Jesus Rosabilbao and his colleagues. If you want to dive deeper, you can find the full paper in the IEEE Internet of Things Journal with the DOI on your screen. Thanks so much for tuning in.